Hello everyone, welcome to NCERT Simplified, and from this video I will start a new chapter number 10 of NCERT Physics. This is mechanical property of fluid. Okay, so in this chapter we have to study about fluid. So the very first question that comes in our mind is what is fluid. So any object, any substance that can flow is called fluid. So liquid and gases have the property to flow, so that's why they are called fluid. Okay, and this is a basic way in which we can differentiate solid from liquid and gases. Okay, then we have to study in this chapter, we have to study about pressure, streamline flow, very important Bernoulli's theorem, viscosity, surface tension, Roche number. Okay, so now the second paragraph is not very important. Okay, third paragraph, just see. Now we'll start from the third paragraph, the introduction paragraph. How are fluid different from solids? What is common in liquid and gases? Okay, so as I told you, the basic difference between fluids, liquid and gases is that liquid and gas can flow, but solids, they cannot flow. Unlike a solid, a fluid has no definite shape of its own. Okay, you know, solid has a definite shape, like you see chair around you, it has a definite shape. But solids and fluids do not have a definite shape. They take the shape of the container in which they are kept. This is a very basic thing that you have studied in the small classes. Solid and liquid have a fixed volume, whereas gas fills the entire volume of the container, and this is also familiar to you. Okay, so liquid and gases, like if you take 20 milliliter or 20 liter, I'll say 2 liter of liquid, okay, water, and I pour it in another container, it will always remain 2 liter. Its volume will not change at all. Similarly, solid, the volume of the solid will be always fixed, but the volume of the gases, they can change. The volume of solid, liquid or gas depends on the stress or pressure acting on it. When we talk about fixed volume for solid or liquid, we mean its volume under atmospheric pressure. The difference between gases and solids or liquid is that for solids or liquid, the change in volume due to change of external pressure is rather small. So when the liquid and solids are applied with external pressure, the change in the volume of this solid and liquid is very, very small. But the compressibility of gases is very, very large, because you know the gases have large spaces between them. That's why we are able to compress them. Okay, you see the example of a balloon. If you fill balloon you will fill air in a balloon, don't fill it completely, and you will able to compress it easily, because there are air in it, and air has space between them, air molecule has space between them. That's why we are able to change the volume by applying very little pressure. Okay, now after this, shear stress can change the shape of the solid, keeping its volume fixed. We have talked about shear stress in the previous chapter. Okay, the force acting tangentially. Okay, it changes like this was a book and we applied tangential force here. So this will be displaced, the upper plane will be displaced from its position, and this is the shearing strain you will develop in it. Okay, so now the key property of fluids is that they offer very little resistance to shear stress. Fluids offer very, very less. The shear stress will be very large in case of solid. Okay, but as compared to liquid and gases, it will be very small. In liquid and gases, it will be small. That's why they are able to flow. Okay, when you apply shearing stress, okay, you apply tangential force here. Okay, what will happen? It will deform, the shape will be deformed, but it will come back. But when you apply force to liquid, okay, tangential force to liquid, what is happening? They are not coming back, they are just flowing. So they offer very, very less shearing stress as compared to solid. So the shearing stress of fluid is about million times smaller than that of solid. Next, we have to discuss about another basic term that you know, but we'll go in depth in this. This is pressure. Okay, so what is pressure? Okay, so there are some examples given here, like the very basic and very, very useful example to understand is, okay, needle. thumbnail is a very thumbpin is a very good example to understand pressure. Okay, you see in thumbpin, this side is pointed and this side is broad. Okay, so if we apply force to this side, okay, it will be you are keeping it in on the board, notice board. So what will happen? It will be pierced inside the notice board. Okay, but this part is not going in our hand. Okay, why? Because the force applied on this side is same and the reaction force will be equal. Okay, we are getting the same force on our thumb. The force we are applying on the thumb pin and the thumb pin, because when we push it in against the notice board, it will applying a reaction force that is equal to the force that we are applying. Okay, so we are getting the same force, okay, in return. But what is happening? The thumb pin is not going inside our hand. Why? Because the area of this thumb pin, this head part of the thumb pin is large, very large as compared to the pointed part. That's why we have a term for this, the pressure. Okay, force per unit area. We need to compare this, how much force is in this area part and how much force is in this point. You see, you can consider this whole head of the thumb pin, okay, as made up of very small points. Okay, so the area, the force in this point, the force, you know, as I told you, I applied suppose 10 Newton force to this side. Okay, so 10 Newton force we applied on this side, also the reaction force, but because of the large area it has been distributed. So how much each point is getting? Suppose imagine there are 10 points here. So each point is getting 10 divided by 10, that is 1 Newton force. Okay, I'll apply. So how much force this small area, small unit area is getting? 10. Okay, and how much this is getting? This unit area 1. Force was same, but the force per unit area is different, and this has a name, pressure. Okay, so basically pressure is the force per unit area. How much unit area, the amount of force it is getting, this is pressure. Okay, so there are some other examples given in this, like the elephant, you know, there is in circus you see, if an elephant puts his step on a man's chest, definitely he's gonna die, his rib would crack. But if what he does in a circus, he puts a big plank, a very big plank, and then the elephant puts his leg on the feet on the man on the wooden plank, and his life is saved. Okay, because the force of the elephant feet is been distributed, so each point is getting less in force. Okay, and the pressure, the force per unit area is less. Okay, the pressure is less, hence his life is saved. So you have got the idea what is pressure. Okay, and how it depends. Just increase the area and you will get the force will be distributed and the pressure will be less. Okay, and if you decrease the area, like case of a thumb pin, okay, or a needle, the area is very small, so whole pressure is on that point, we say the pressure is very high. Okay, so even you see a lot of other example. If you are holding a pipe, and from the pipe water is coming out. Okay, so it is coming out with some force. What you do, you cover half of the pipe, and suddenly you see the pressure of the water coming from the pipe increases. Why? Because the area, you have decreased the area. So on decreasing the area, pressure will increase. Okay, now let's move forward and just read more about this. There are more things given in this. I have given you the basic idea. The unit is Pascal, the unit of pressure is Pascal, and even we can figure out the dimension of this. For the fourth dimension is mlt minus 2, area dimension is l square. So on equating this two, we'll get ml to the power minus 1 t to the power minus 2. Okay, it is a scalar quantity. This is a very not a very common thing to understand. Okay, very usual thing to understand. Like you see, force is a vector quantity and this area is a scalar quantity. A vector divided by area, this should be a vector quantity. But which force we have to emphasize here which force we are considering. The force we only consider in pressure is, just look at the definition here, this point, component of force normal to the area under consideration, not the vector force that appeared in the numerator. Okay, so we are not like this is the area where force is applied. The force is applied in this direction. Are we concerned with this direction of force? No, we are not. We are not concerned with the direction of the force. What direction we will always take? We are only concerned with the magnitude, that is acting perpendicular, and not this direction. The actual direction we are not considering for force. So direction of force is excluded. Okay, only the force which is perpendicular. So we have to take this component of force. Okay, so that's why we are not taking the vector force here, only the force which are normal. Okay, so direction is out of the equation. So that's why this is a scalar quantity. Newton per meter is the unit, Pascal. Okay, this is Pascal and name after Blaise Pascal. Okay, some more units are there common in the like this is atmosphere. How much is atmosphere? So the pressure the pressure exerted by the atmosphere at sea level, it is 1 atmosphere, which is equal to important conversion. You should remember this, 1.013 into 10 to the power 5 Pascal. Okay, and again there are some more things, like suppose the force is not uniform. Okay, then how to calculate force? So we'll just take the small area and this area will tend to 0. In the limit of area tend to 0, force will be what? dF by dA. Okay, we will consider with the small change, small area, how much force is acting on the small area, that will be the pressure. Okay, and more things are there. Then there is the density is mentioned. This is also given. Okay, third law. Okay, we just look at this also. Pressure I had told you. Okay, when an object is submerged in a fluid at rest, the fluid exerts the force on its surface. This force is always normal to the object surface. This point is also important to understand. Okay, now what happens? Okay, let's see. Just let me draw this. An object is submerged in a fluid. Okay, so what will happen now? The object will exert force on the surface. This object will exert force on the surface. In return, what will happen? The liquid will also exert force on the object. Okay, but just remember, this force is always not to the surface, object surface. The force exerted by the fluid will always normal to the surface. Okay, this is because you see, if the force exerted by the liquid is not normal, suppose this force exerted by the liquid is tangential, okay, like this. Okay, then again what will happen? In return, this object will exert force in this direction opposite to this. Okay, now we can draw two component of this. Okay, and you see this component is horizontal to the plane of the liquid surface. Okay, and that's why if there is a normal horizontal component in the direction horizontal to the surface, it will make the liquid flow. Even the body is at rest, this object is at rest, but because the liquid is exerting force in this direction and not normal, then because of reaction there will be horizontal component of reaction force by the object on the liquid, and that will make the water flow, but this doesn't happen. So we have to conclude that because of object which is at rest on a liquid surface, the liquid is not flowing. That's why the pressure exerted by the fluid on the object should be normal, always normal. Okay, then we'll go to the next paragraph, and in this the density thing is mentioned. You know very well know what is density. It is mass per unit volume. Okay, again we consider a unit volume. Okay, suppose two objects are, there are two blocks of copper, and one is of copper and other one is of iron. Okay, I'll consider a unit area, unit volume of this unit volume. I'll take the unit volume and measure their masses. Okay, I'll find that the mass of this iron is more, maybe copper is more. You can see the density which has more density. I think iron has more density, so the mass of this unit volume of iron will be more, and the mass of this unit volume copper will be less. So we have given that a name, density. So we'll say the density of iron is more, because, and the reason for this is because the particles of iron, the atoms of iron are closely packed as compared to the atoms of copper. Okay, that's why it's a large density. Talking about because we are dealing with this chapter about fluids. So what is the density of water? And you will see when we'll read it in anomalous expansion of water, you will see that water expands show very anomalous behavior, very different behavior on decreasing the temperature from 4 degrees to 0 degrees Celsius. What should happen on decreasing the temperature? The volume should increase or decrease? The answer would be it should decrease, but surprisingly opposite happens. Its volume increases, and this is the anomalous expansion of water. And because of this, the density of water is maximum at 4 degrees Celsius. Okay, at 277 Kelvin, and that is 1.0 10 to the power 3 kg per meter cube. So this is the density we consider often at 4 degrees Celsius. This is 10 to the power 3 kg per meter cube, or in gram it is 1 gram per centimeter cube. Okay, so now again density is scalar quantity, unit is kg per meter cube as a unit. And we have another concept here, very basic concept, very common concept. Okay, just see relative density. It is also called specific gravity, not mentioned in here NCERT, but it is also called specific gravity. Okay, and this is relative density. So as the name suggests, it is the density of a substance relative to what? Water at 0 degrees, 4 degrees Celsius. Okay, so I'll say the relative density of, just what is relative density of aluminium? So the density of aluminium is this much. Okay, the relative density of aluminium will be 2.7. Why? Just divide the density of this aluminium by density of water. Okay, so this will be cancelled out, 2.7. So this means, what does relative density signifies? It signifies how much the substance is denser from as compared to water. So aluminium is 2.7 times denser than water. Okay, so here the list of densities of different substances, and from density you know that if a substance is denser than water, it will sink on water, whereas if its density is less than the density of water, it will float. Okay, from this you can easily find out which sinks and which floats. After this we have a law, Pascal's law, given by Blaise Pascal, and what does it tell us? It tells us that the pressure transmitted through an enclosed liquid is transmitted equally and in undiminished way to all parts of the liquid. Okay, let me see where it is given, the Pascal's law. Yeah, it is given here, I think. Okay, let's just read the whole paragraph, then we'll I told you this Pascal's law. Basically it says that if you know actually it is very easy to understand it by when we are taking example of this application. Let me see the application. Where is the application given? I don't think the application is given, but I'll just give you this application. I'll draw the application, and it is easier to understand Pascal law by the application. Okay, you see there are two devices, other devices are there. Yeah, I'm considering two devices: hydraulic lift, hydraulic brakes. Okay, hydraulic press is also there. Okay, so in hydraulic lift what happens, the diagram or the construction is a little different, but I'm just drawing a basic figure, okay, to give you an explanation. So what is happening is, let me draw it a little better. Okay, so this is a enclosed tube. Okay, enclosed tube, and a liquid is filled in it. It is enclosed tube. I have enclosed it here. So the first condition should be the liquid should be enclosed. Okay, enclosed liquid should be enclosed in a tube or in a container. Okay, then it says that if we apply pressure on in an enclosed liquid, okay, obviously it should be incompressible, cannot be compressed, the fluid. Then the pressure that we exert on a fluid, it will be transmitted equally and in undiminished way in all the directions. Suppose I exert 20 Pascal pressure on this side, it will not differentiate where to go more, where to go less. It will be transmitted in all directions. At any point you check, the increase in pressure will be more everywhere. 20 times the pressure will be transmitted equally. This is a very interesting study. You can check it out on YouTube. Even you can do this experiment. Okay, what you do, you just take a water bottle. Okay, then you put holes in different parts of the water bottle. Okay, and you have to cut it bottle. Okay, because you have to insert a piston on it. Okay, syringe you can insert. Okay, then when you fill this water bottle, and immediately you just push the piston, okay, the syringe, and you see the jets coming from this different parts of the bottle are the pressure. Suddenly when you apply the pressure on the syringe, the jets will be, and all the jets from different position will be of same distance. Okay, it is not like that this jet will be very different in size, this is small in size. All the jet will suddenly they will go the same distance. Okay, this proves that what pressure is transmitted equally in undiminished way. Okay, coming back to this hydraulic lift example. So what happens is, this is the pipe, enclosed pipe, in which the liquid was kept. Okay, the fluid was kept. It may be oil, it may be water. Okay, so there is this is the place where we put the vehicle, the car. Okay, load is kept here, and we apply force here. The area, you see, the area is small here. Okay, suppose the area is 2 here. Okay, the area here is 20. Okay, the pressure should be same. Pressure 1 should be equal to pressure 2. Why? Pascal's law. Pressure is equal to transmitted equally. Pressure is force upon area, and pressure is force upon area. F1 upon A1, F2 upon A2. Okay, from on rearranging you will find F1 upon F2 should be equal to let me check just a second. F1 upon A1 is equal to F2 upon A2. So this should be, yes, F1 upon F2 should be equal to A1 upon A2, and very clearly you see I drawn that the area 1 was smaller as compared to area 2. This should be smaller. So similarly, because this is smaller than 1, F1 upon F2 should be smaller than 1. That is, F1 up 2 is smaller than, this is greater, F1 upon F2 is smaller than 1. So this means that F2 is greater than F1. Okay, so that means the force will be greater where the area is greater. The more do you increase the area, the more force you will generate by applying a very small force. Okay, this is because of Pascal's law. Okay, similarly hydraulic brakes are there, the same principle is there.